let's take a look at an example. Suppose search and rescue teams work to find lost hikers in remote areas. To search, members of the search team separate and walk parallel to each other. Experience has shown that the team's chance of finding a lost person is related to the distance d by which the teams are separated, with %p found equal to p equals f at d, given in the table below. So at a distance in feet of 20, 40, 60, 80, or 100, the percent found would start at 90, drop to 50, going 90, 80, 70, 60, 50. Part A. How can we tell from looking at the table that this is a linear function? Well, remember, linear functions have constant slope. So let's take a look at the slope. Notice in each case, the inputs go up by 20. Right? While the outputs go down by 10. So notice, no matter which points we pick, our slope will always be constant. And remember, if we do it the proper way, with delta y over delta x, we get negative 10 over 20, or negative 1/2, and we could look at that as percent per foot. Now then they ask us, what is the slope? Well, that slope is that constant value we get every time we compute delta y over delta x, negative 1/2% per foot, or negative 20% per foot. Now what if I want to interpret the slope? What does that tell us? Well, notice if I take, and I'm going to use the original, the negative 10 over 20 and percent per foot. Notice if I assign the negative to the numerator, what this now tells me is if the distance increases by 20 feet, the chance of finding a lost person drops by 10%. Or we could say if the distance increases by 2 feet, the chance of finding a lost person drops by 1%.